Welcome students to the course of algorithms. So today we are going to learn about the algorithms, the basic definition of the algorithms, the pseudocode conventions, and the analysis of algorithms. So algorithm is a general solution of a problem which can be written as a verbal description of precise logical sequence of actions. So if we define algorithm, it is just a sequence of steps. So we have seen and we know algorithms in our day-to-day life. It's just that we don't see them in the perspective of a series of steps because we just assume that we know how to do things. Okay, so if we see that you have to cook, your rice, or you have to make tea. So for that as well, what you do is that you use a set of steps. For example, to make tea, you have to get water and boil it, and then add milk, and it will bring it will make tea. So when it comes to algorithms, we have certain different things, like we have cooking recipes, we have assembly instructions for appliances, or if your friend will ask you for directions to reach his home, that also accounts for the algorithm. So when we talk about computer program, a computer program is when you express an algorithm in terms of a programming language, it becomes a computer program. Okay, so let's take a simple example of an algorithm so that you will get a grasp of what algorithm means. What I'm going to do is that I'm going to write an algorithm to check if a number is even or odd. So what I'll do is that I'll simply write algorithm and its name, even, odd. You can write any name that makes any sense to you. After that, I'll write begin, because begin will show that I have started this algorithm from this point, and then I'll write enter a number. So a user will enter a number, and next what I have to do, if I have to check that if that number is even or odd, I have to simply check that if it is divisible by 2 or not. So what I'll do is that I'll check that if number is divisible by 2. Okay, so simply what we will do is that we'll print that number is even. Else what we'll do, the number is odd. So else print the number is odd, and then we will end it, because I just want to check a single number if that is even or odd. So what I have done is that I have just given a verbal description as a set of steps, and this is an algorithm. It has a name, and of course there are some things that might be new to you, but we will learn them as we study more about algorithms, the conventions that we use for an algorithm. Okay, so next what we are going to do is that now this is a general algorithm, but when it comes to computer sciences, there are certain properties of an algorithm when it comes to computer sciences. So for computer sciences, an algorithm has 5 properties. The first property of the algorithm is finiteness. So what finiteness means is that your algorithm can have any number of steps, but eventually your algorithm should stop. Your algorithm should not be as such that it goes on forever, because when we run a program on a computer, we expect it to end after some time. So the first property of the algorithm is the finiteness of an algorithm, means after a certain time. That time can be 1 second, it can be 1 minute, it can be 1 hour, but eventually that algorithm will stop. The second property is definiteness. When it comes to human beings, we know that we have a certain knowledge that we know how to do things. But for a computer is a dumb machine. We need to tell everything to a computer how to perform that task. So definiteness means that if we are giving a certain instruction to a computer, it should not be ambiguous. There should be a clear-cut direction what to do. So that means definiteness. We cannot ask a computer, say, we have some number x, we'll divide it by 0. So that will create a problem. And whatever instructions we are going to give to a computer in our algorithm, that should be definite. Means they should be unambiguous and they should have a definite meaning. Okay. The third one is effectiveness. So effectiveness means that whatever you write, whatever step you write for your algorithm, that should be you should be able to convert it into something which is doable. Means a simple person should be able to write whatever whatever step you have done. A person should be able to compute that step with the help of just a paper and pencil. So he should be able to execute that step. When a person will be able to execute that step, a computer will also be able to execute that step. So that means effectiveness. You should not write something which you cannot do yourself. So then a computer cannot do that as well. Okay. So the fourth one is input. So this is actually this is not a necessary criteria. Why it is not a necessary criteria? Means that an algorithm can have 0 or more inputs. Means either 0, your algorithm doesn't take any input, it does some work on its own. Say it's displaying 100 numbers, or it's displaying Fibonacci series or prime numbers. So in that case, you don't need to give any input unless you want to give it the limit up to which to print. So for input, your algorithm should have 0 or more. Means you can, this step is not necessary, okay? But it's not necessary for that algorithm which does not interact with user, which does not take any input from users. The last one is output. So output is necessary, 1 or more. So you can see here I have written 0, but here I have written 1. So an input is 0 or more, means the input is not necessary, but an algorithm can take input. The fifth property is output, means an algorithm should definitely give some output. Why is this important? You can imagine, what is the fun of an algorithm or a computer program which does something and has 0 output? Means it doesn't give you any output. Output is not necessary that you will get it in the form, it will be displayed on screen. Output means doing some work, okay? So it should have an output, it should have 1 or more outputs. So now when we look at these, these properties of a computer algorithm, we can say that an algorithm has a slightly different definition when it comes to computer science, and that is that algorithms is steps of finite set of steps, finite set of unambiguous steps, okay? And what will they do? We take some input and produce some output, okay? So these are the 5 properties of an algorithm. Now there is one, one property, that is finiteness. This is a little debatable because there are certain algorithms which are not finite. Finite means that they don't stop, okay? So the example is of your operating system. If you look at your operating system, what happens is that your operating system, once you switch on your computer, your operating system is running, okay? So even if you don't do anything, it does not terminate, your computer doesn't shut down, but it is still running. So it is waiting for you to provide some input. Or there's a web server, it is waiting for somebody to ask for a service and it will provide it that service. So that category of algorithms is known as, we call them computational algorithms, okay? So they, they defy this property that they are not finite. They don't stop after a certain number of steps. They are running in background, like I have given you the example of your operating system. So our, our focus of algorithms will be the general algorithms and not these computational algorithms, fine? So now we'll see the next topic, next subtopic, that is the pseudocode conventions. So in the definition of our algorithms, I have told you that the algorithms is just set of steps where we can give some verbal descriptions to it. But then we saw that when it comes to computer sciences, an algorithm should be, there should be definiteness, means there should not be any ambiguous statements in your algorithm. So what happens is that if you write an algorithm for yourself, you can write it in any way you want because you are going to read it yourself, so there will be no confusions. But if you are going to write a general solution to a problem and many people are going to read it, or somebody else is going to convert it into a program, at that time you need to follow some conventions so that there is no confusion that whatever you have written, it should not have ambiguous meanings. So for that we have pseudocode conventions that we need to follow. So these are not actually that hard and fast. You should not confuse them with the programming conventions. Means if you are learning C language or Java, then the syntax of that language is very hard. You have to follow that exact syntax, otherwise there will be compile time errors and there will be syntax errors. But when it comes to pseudocode conventions, it is something that you have to understand. There is a little bit flexibility. It's not hard and fast that you should write in a particular way. You can improvise on your own, but what you have to do is that you have to follow a certain standard in your algorithm, throughout your algorithm, okay? So if you're using one style for something, you have to use the same style for throughout your algorithm. You cannot use one thing at one place and some other thing at other place. So for pseudocode conventions, we have to see the first thing, that is your computation agent. So whenever it comes to writing an algorithm, the thing that you have to keep in your mind is your computation agent, means the place, the system where finally your algorithm is going to get executed. So here we know the computation agent will be your computer where you will finally convert your algorithm into a program. So you have to keep that computation agent in your mind, and then you have to see what you need to write your algorithm on that computation agent, okay? So the first thing that you need to take care of is the state. So the first thing that you have to save is the state of your computation agent. And what comprises of the state of your computation agent? Whenever you are writing a program, you have different variables there, and those variables have different values, or you have different objects of a class, and they are, they have some value stored in them. So basically, state of the computation agent is described by the value of particular variables which you have, which you are using at that time. So to save the state of a computing agent, you simply need variables, and what you do is that you use simple names for your variables. For example, if you have name of a, you have to save the name, you will write simply name. You have to save salary. So what are these? These are simply variable names. So there is nothing special here. You just simply write those variable name with a proper name, so that you don't confuse that, oh, what does this variable means, okay? You can use X for name, but it will make confusion, because when it comes to algorithm, it is more descriptive than your program, okay? So it's better to write a variable name which describes what type of value that variable is holding, okay? So just like normal programming, syntax, sometimes if you have to save, say, value of 10 persons, so at that time you won't use 10 different names. What you will do, you use an array. So same way we can use here. We can use, if we have to save, say, name of 10 people, so we will use an array, okay? So it will be of size 10, and then we'll be having indexes, like we'll be having name 0, name 1. So they will refer to the name 0, means 0th element, name 1, the first element, okay? So here you will be using another thing, that is the index. It is same as you use in arrays, okay? So after the state of the computing agent, the next thing is expressions. So what is an expression? Expression is nothing. Expression is a place where you use the variables that I had defined just now, plus you use operators, mathematical operators, like you use plus, minus, into, divide. So if we are having, say, two values, so we can write value 1 plus value 2. So this will be an expression. Same way that you write an expression in a program, you can use it over here and write it, okay? So these expressions will have, and obviously they will have an integer or a float, means it will have a numeric value. There are some expressions which don't have numeric value. They have what we call a Boolean value. Boolean means true or false. So in that case, if you use value 1 greater than value 2, so that case you are using, here you are comparing these two. So here the value, here the return or the, the final outcome of this expression will be an integer or a numeric value. But here, if we are checking if value 1 is greater than value 2, it will be a Boolean value, means it will be true or false. So we can have an expression where we can have true or false as the outcome of your expression as well, and we write them like this, okay? So in pseudocode conventions, we will see the next thing, that is, if you want to iterate means you need to repeat things, okay? You need to repeat a set of steps for some time. So for that we have iteration. So what we will do, we will simply write repeat, okay? Then we will write while, and then condition, okay? Then we can write the steps, whatever things you want to repeat in this while condition, and then we will write end. Fine. So there are certain variations to this as well. It is not, like I said at the beginning, this is not a programming language, okay? So we are not concerned here about that much about syntax. So there is a little bit flexibility here. You can write repeat, while, and then this will be the condition that you have to check. Only then you will repeat this. You can write here do statements and then end, okay? So basically what you are doing is that you are also using indentation. Indentation means that, like we follow while writing our program, is that we indent the statements a little bit towards the right side, so that we'll understand that it is going, this is the loop, okay? It's going to repeat from here to here, okay? So as you know, there is do while and while do loop. So this one will check the condition first, and only then these statements will be executed. So what we can do is that we can also make it like do while. What we have to do is that we have to repeat these statements, and we'll do these statements, and then we'll write while condition, and then end. So this way what will happen, it's now inverted, it will become your do while loop, okay? So another type of iteration is that you have seen is for. So for is another a construct for iteration. What we can do is that we can write for I equals, say, 0 to whatever value you want it to n, then do. You can do some things like you will write statements here, and finally you will write end, okay? So this is another way of writing statements if you want to iterate through them for n number of times, okay? So after iteration, there is also another construct that is for your what we call that conditions. So if you want to check conditions in your algorithm, what you have to do is that you have to check a certain condition, then only you have to execute a certain code. Like in the example that I showed in the beginning, where I checked if a number is even or odd. What I did is that I wrote if a number is divisible by 2, then print it is even, and then I wrote else print it's odd. So that if and else is actually what? It's conditions. We are printing that the number is even or odd. So for that we can simply write if, then we'll write here condition, and then we'll write statements. Again we can write here do or not. If we don't write, doesn't matter, because it's not a program. Again, it's not going to be compiled, so you don't need to worry that much about. But you have to follow a certain rule. Either you write do everywhere in your algorithm or you don't. And here we'll write end. Fine. So this is your if, and similarly if you want to add if you want to add else to your loop, you will write else, and then you will write statements, and then you will write end, okay? So this is how you check the conditions and how you iterate through your loop. And finally, I have also showed you how to use variables and how to use expressions in your algorithm. So like I said, there is no hard and fast rule that you have to use that only. So if you have to assign, say I'll give you an example, if you have to assign a value to a variable, okay? So what you can do is that if you want to assign a value to a variable, you can simply write variable name. You can write set variable name and value. What does that mean? You can write set, say name, and then you can write here name, say John. So what will happen is that you are assigning John to this variable name. Again, you can use set, you can write x and then you can write 10. So what you are doing, you are storing the value 10 into this variable x. So you can also write like this, x 10. This is also a proper way to show that you are using, you are initializing or you are assigning value 10 to this x. Or you can write x 10. This is also correct. So now there might be a question or a confusion in your mind that which one we are going to follow. Like I said, there is no hard and fast rule. If you are using this set x10, then ensure that wherever you are assigning value to a variable in your algorithm, you are using this set. If you are using x and then you are using arrow 10, then ensure that in your whole algorithm you are only following this. And similarly, if you are using x then colon and equal to 10, then ensure that in your whole algorithm you are only using this statement, okay? This type of assignment statement. So we have seen pseudocode conventions. Using these pseudocode conventions, let us now write again that algorithm that we used at the beginning of our lecture, that was to check if a number is even or odd. Again, I'll name it even odd. So now what I'll do is that first of all, I have to show where this algorithm starts. So I'll write begin. You might read, in some other books, you will see that they have written start instead of begin. So again, it's not necessary that you write begin, you can write start, doesn't matter. So then I'll say what I'll do is that I'll print, I'll ask user to input some number. So for that, I'll use print. So print here is not a command or it's not something that is going to execute, but it's just to let you know that whatever you are writing after print, it's going to be displayed as an output, okay? So you can write print, you can write display, whatever you are comfortable with, okay? So I can write print, then I'll write enter a number, okay? Simple. So I have written it in inverted commas because I want this statement to be printed. So what I'll do is that I'll set val is a variable, a simple variable. So I don't need to declare it. So you might confuse it like, if we are using a C program or a Java program, what we do is that before using this val or this variable, we have to declare its type. Because this is an algorithm, we don't go into that detail. That will be when we will implement this algorithm in terms of a computer program, okay? So here we'll simply write set val to the entered number. Means whatever number has been entered by the user, that will be set to val. Then I will write if val mod 2 equal to 0, okay? So people might confuse this equal with assignment operator. So what we can do is that we can simply write it in, because this is a description, we can write if vadmol2 equals 0. This is the condition. If val is the variable, will mod operation, modulus operation, what it is gives you integer remainder. Means when we divide this number with 2, it will give you the remainder. So if it is an even number, what will be the remainder? It will be 0. So if it equals to 0, then again we'll use print. Number is even. So one thing I have to keep into mind is that, like I said, instead of print, you can write display. So if I've written print here, I have to ensure that I am again using print here. So if I write print here and then display here, some other person reading my algorithm might confuse it, that why are there two different statements, okay? So you have to follow a certain standard, whatever you are following, okay? So if val mod 2 equals 0, print number is even. And then, because we are out of space here, I'll write it here. Else print number is odd, okay? And then end. So this is the end of this if, okay? After that, I have to end this procedure, so I will write end here as well. So this end will refer to this begin. That means this procedure has ended. Fine. So this is a very basic and a trivial example of an algorithm. We will be writing algorithm which will be, mostly doing things that like, sorting an array or finding an element in an array. So at that time, we'll be doing things that will be more mathematical, and we won't be using that much of natural language to write our algorithms. So this is just to give you an idea that the pseudocode conventions, what pseudocodes we follow, how do we follow, okay, in our algorithm. So I have given you the ways to show variables, arrays, expressions. We have seen how to use conditions, that is if, while, and we have seen the iterations, and in iterations we have seen do until, we have seen do while, and we have also seen for loops. So this is just to give you an idea that you already have that programming, maybe you have that programming knowledge in your mind. You have to now write it in a more descriptive form. You don't need to go into the details of a particular syntax. You just need to add a little bit description to it, and you have to be homogeneous. You have to be throughout, you have to use same nomenclature, whatever you choose, okay. So this finishes our pseudocode conventions. So the next thing that we'll be learning is the analysis of an algorithm. First of all, I'll tell you why do we need to do analysis of algorithm before telling you what analysis of algorithm actually means. So like I said, the first property of an algorithm is the finiteness, means that an algorithm should stop after a finite number of steps. But let me give you an example of an algorithm which is used when you play chess, okay. So say you are playing chess, and at a particular moment you are at, there is a player, there are two players, player 1 and player 2, they have played some steps, and now you want to know that the current position that you are, is it possible for you to win? So what that algorithm will do is that it will take the permutation and combinations of all the steps that you are going to play from that point onwards. Not only your steps, but the counter steps as well of your opponent. And then it will determine if your current position will lead to a win or not. So when we speak of such algorithm, although we know what the steps are, we know what it has to do, but even even if we execute that algorithm on the very fast computers that we have nowadays, it will take billions of years. So practically that algorithm is not, it's not viable, that algorithm. That comes into a category of algorithms that we call NP and NP hard, which we are going to learn towards the end of this course. But so we have to see that is algorithm viable, is it feasible to write that algorithm. So for that we do analysis of algorithm. So algorithm analysis, we focus on two things. One is space and another one is time. So whenever an algorithm is converted into a program and is executed on a machine, it takes space on that machine. So that space will be both primary as well as auxiliary. Primary means whenever that program is being executed, it is on your RAM, and auxiliary means if that program is taking some input, storing data, it will use your auxiliary storage. And time means your CPU time, okay? So analysis of algorithm is nothing, we just focus on these two things. We see how much space and how much time your algorithm is taking, okay? So now, why do we need to analyze algorithm? Obviously, I told you the first reason is to see if your algorithm is viable or not. There are some people who also do it just for fun, means they want to see, they want to analyze, they want to see, okay, a new algorithm has come, let me see how much time it's going to take, how much space it's going to take. And there are some people who do it because they want to optimize algorithms. Means there are many ways of sorting an array. You have merge sort, you have binary sort. So some people might think which one is better, or if I want to give another algorithm which will be better than both of them, okay? So at that time also you use analysis of algorithms, okay? So there are only two parameters for analysis of algorithm for now, that is space and time. There are other parameters as well, like there is bandwidth, when it comes, if it's a web-based application, but we won't go towards that portion. We'll only focus on the space and time of your algorithm, okay? So as an example, I'll just give you a little example to get an idea of this algorithm, analysis of algorithm. Say we have a simple program, so I will write that. We have a variable x, and we are adding two numbers, a and b, and I'm storing that value in your variable x, okay? So what I want to do is that I want to check that if I write this statement in different ways, how is it going to affect the time of my algorithm, the execution time of my algorithm. So what I'll do is that I'll simply write a statement x a plus b, and in another program I will write for I equal to 0 to n, so I have written 3 fragments here. You should not worry about what these algorithms are doing. Actually, we are trying to learn here the concept of analysis of algorithm, okay? So these 3 programs, what I'm focusing on this statement, that is x is equal to a plus b, okay? So one way to analyze the algorithm is to count the frequency. We'll simply see how many times this statement is executed, okay? So if we see here, this statement is executed once, okay? And if we see this algorithm, here this statement will go from 0 to n, okay? So this statement will be here executed n times. And here if we see, we are having 2 loops. One is outer loop and another one is the inner loop. So here what will happen, outer loop will execute n times and inner loop will execute n times. So total it will execute n into n times, okay? So if we see, this loop will also execute n into n times because it is included in the outer loop, and similarly this statement will be executed as many times as this inner loop is there. So n into n is your n square. So if we talk in the basic term, what analysis of algorithm is that whatever algorithm we have written, we'll simply count the number of frequencies of the statements that we have written, and we'll see how much time it takes to execute for that algorithm, okay? So this one is 1, this one is n, and that one is n square. So we all know that we have 3 values here. We have 1, we have n, and we have n square. So we all know that 1 is less than n square. Why? So this one, you will say that maybe if n has 1 value or 0 value, then it will not be less than 1. But what I am trying to say is that this is a fixed, this takes fixed time, okay? So this 1 means it is going to take fixed time. No matter what happens, this algorithm is going to take fixed time. Here it means n, means whatever the size of the input is, it is going to take that time. And here it is n square times. So it is going to take more time than this one. And this one, because this is constant, that's why I'm saying that it is less than n. So that's a different debate when we'll see that if n equal to 0, what will happen at that time. But what I'm trying to highlight here is that it is taking a constant time, it is taking the input time, and it is taking input time but squared. So this is one way of analyzing an algorithm, and this helps us actually understanding how our algorithm is going to work over time. Okay, so what we are focusing in analysis of algorithm is that we are going to see the performance of our algorithm as a function of input. Means this input, this is size n, and this is n square. So we are seeing that the function, if we take it as a function, so this is a constant function, this is n. So we can say that here the analysis is f of n. Means this algorithm is linearly working with respect to the input size, and this one is f of n square. Means it is a quadratic equation. So it is square times the size of your input. In today's lecture, we saw the algorithm, we saw the introduction to the algorithms, what algorithm means, okay. Then we saw the properties of an algorithm, we saw the 5 properties of the algorithm. After that, we saw the pseudocode conventions, means if you want to write an algorithm, what conventions you should follow. And those conventions I showed you, they are more or less same as you write your program, but you don't go into that much detail, and there is a little bit, that's why we write pseudocode. It's not code, it's pseudocode. We use some, you can use your natural language words so that to make it a little bit more descriptive. After that, we saw a brief introduction to analysis of algorithms. But we haven't actually seen how we analyze an algorithm. That we will be seeing in the next lecture, where we will see the space and time complexity which play the major role in the analysis of algorithm, and that will be the topic for our next lecture. Thank you.